Hello students, welcome back to Future Foundation. Students, in this video I am going to discuss question from complex numbers which was asked in JEE Main 2025 held on 29th Jan Shift 2. So let's start. So students, question is integer based and the question says let integers a comma b belongs to minus 3 comma 3 closed be such that a plus b is not equal to 0, then the number of all possible ordered pairs a comma b for which mod of z minus a upon z plus b is equal to 1 and determinant of z plus 1 omega omega square omega z plus omega square 1 omega square 1 z plus omega is equal to 1, where z is a complex number and omega and omega square are the roots of x square plus x plus 1 is equal to 0 is equal to. Students, question might be bit lengthy, so have some patience. So first of all, I am taking determinant part. So determinant of this is equal to 1, that is determinant of z plus 1 omega omega square omega z plus omega square 1 omega square 1 z plus omega is equal to 1. Now I am taking operation in row 1 and operation is row 1 plus row 2 plus row 3. Okay, so from this will be z plus 1 plus omega square z plus 1 plus omega square z plus 1 plus omega square omega z plus omega square 1 omega square 1 z plus omega and it is equal to 1, right? Now 1 plus omega square is 0 as it is given in the question that omega and omega square are the roots of x square plus x plus 1 is equal to 0, right? So omega and omega square are the roots of this equation. So 1 plus omega square will be 0. Okay. So it will be left. What will be left? In row 1 z and I will take z as common. So z times 1 1 1 omega z plus omega square 1 omega square 1 z plus omega is equal to 1. Now again I'm applying one more operation, and that is, in fact I'm applying two operations, one in column 1 and other in column 2. In column 1 I am making c1 minus c3 and in column 2 I am making c2 minus c3 simultaneously. So then it will become z times 0 omega minus 1 omega square minus z minus omega 0 z plus omega square minus 1 1 minus z minus omega 1 1 z plus omega is equal to 1. Now I am expanding this determinant because I have two zeros in row 1, so determinant can be expanded very easily, right? So z times omega minus 1 into 1 minus z minus omega minus z plus omega square minus 1 times omega square minus z minus omega is equal to 1. Okay, now just multiply inside bracket and it will be omega minus z omega minus omega square minus 1 plus z plus omega, right? Minus of z omega square minus z square minus z omega plus omega to the power 4, that is omega, minus z omega square minus omega cube, which is minus 1, minus omega square plus z plus omega is equal to 1, right? Now I will have z times omega minus z omega minus omega square minus 1 plus z plus omega minus z omega square plus z square plus z omega minus omega plus z omega square plus 1 minus plus plus omega square minus z minus omega is equal to 1, right? And terms will be cancelled out. So inside bracket only z square is left. So z into z square is z cube. Z cube is equal to 1. So if z cube is equal to 1, then z is equal to 1 omega and omega square, right? Now I have information for z. Now come to next information, which is mod of z minus a upon z plus b is equal to 1. Mod of z minus a upon z plus b is equal to 1 gives you mod of z minus a is equal to mod of z plus b, right? Now if I take z is equal to 1, then it will be mod of 1 minus a is equal to mod of 1 plus b, or 1 minus a whole square is equal to 1 plus b whole square. 1 plus a square minus 2a is equal to 1 plus b square plus 2b, right? So a square minus b square minus 2a minus 2b is equal to 0 gives you a minus b into a plus b minus 2 times a plus b is equal to 0. Or if I take a plus b common, then inside bracket what will be remaining? A minus b minus 2 is equal to 0. As a plus b is not equal to 0, it is given in the question. So from here a minus b is equal to 2, or a is equal to b plus 2, right? So from this equation I can take a and b. Now if b is minus 3, a is minus 1, b is minus 2, a is 0, b is minus 1, a is minus 1, b is 0, a is 2, b is 1, a is 3, and b cannot be 2, because if b is 2, then a will be 4, which is not, a will be 4, which is not valid, because a and b belongs to minus 3 to 3 closed. In this case a is 1. Here middle one is not possible because of a plus b is 0 in this case also, right? So 1, 2, 3 and 4 ordered pairs are possible if z is equal to 1. If z is equal to omega, and omega is nothing but minus 1 plus iota root 3 by 2, so in that case mod of z minus a is equal to mod of z plus b. So mod of minus 1 plus iota root 3 by 2 minus a is equal to mod of minus 1 plus iota root 3 by 2 plus b, right? So from here mod of minus 1 by 2 minus a plus iota root 3 by 2 is equal to minus 1 by 2 plus b plus iota root 3 by 2, and if I take a square both sides, then it will be 1 by 2 plus a whole square plus 3 by 4 is equal to 1 by 2 minus b whole square plus 3 by 4, right? So 1 by 4 plus e square plus e plus 3 by 4 is equal to 1 by 4 plus b square minus b plus 3 by 4. Okay, 3 by 4, 1 by 4, 3 by 4, 1 by 4 will cancel out. So this will be a square minus b square plus a plus b is equal to 0, gives you a minus b into a plus b plus a plus b is equal to 0, right? So if I take a plus b as common factor, then inside bracket it will be a minus b plus 1 is equal to 0, right? Again a plus b cannot be 0, so here it will be remaining, what it will be remaining, b is equal to a plus 1, right? Now from this equation I can get a and b. If a is minus 3, b is minus 2, a is minus 2, b is minus 1, a is minus 1, b is 0, a is 0, b is 1, a is 1, b is 2, and if a is 2, b is 3. So here there are total 6 ordered pairs possible, right? All are valid. So from if if z is omega, then there are 6 ordered pairs, and if z is 1, then there are 4 ordered pairs, right? So in total there are 4 ordered pairs if z is 1, and if z is omega there are 6 ordered pairs, right? And if z is omega square, then again same 6 ordered pairs will be there, right? So in total number of ordered pairs a comma b is equal to 4 plus 6, that is 10, right? So 10 is the correct answer. So 10. So students, let's meet in next video. Till then, bye bye, take care.